What's up, guys? It's your boy Leetcode, and this is Leetcode 2110, 2110, however you want to say it. Number of smooth descent periods of a stock. So you're given an array an integer array prices, which is the daily price history of a stock. Prices of I is the stock price on the ith day, and a smooth descent period of a stock consists of one or more straight days where the price on each day is lower than the price of the preceding day by exactly one, and the first day of the period is exempted from this rule. Return the count of smooth descent periods, right? The number of smooth descent periods. So, basically, because of this sentence, you're already counting all subarrays of size 1, right? So, or all, I guess, periods, all 1 day periods, right, of just one singular day. 3, 2, 1, 4. That's why you count these right here due to this, right? And so after that, like, kind of uninteresting aspect of the problem, like after this count, your new problem is just find this, right? Find this. And so to find your little smooth descent periods, note that, okay, for this, you have to have 3, 2, 2, 1, and 3, 2, 1. So yeah, inside of each smooth descent period that is greater than size 2, right, there's going to be, like, inside of it, also smooth descent periods of, like, size 2, right? So you have 3, 2, 1, then you have 3, 2, then you have 2, 1. And, you also have 3 and 2 and 1, whatever. So essentially, you want to count this. And so how do you count this, right? So I'm going to do this 3, 2, 1, 4, right? No, 3, 2, 1. Right, yeah, that's 3 right here. That's 3 subarrays. So yeah, your equivalent problem is going to be essentially, once you find, like, this period right here, you count your number of subarrays, right? And what's your number of subarrays? Well, that's just n times n plus 1 over 2, where n is your subarray length, right? Or your array length. And that's the number of subarrays of an array. And so you can actually use that, sorry, that's my editorial, to find the number of subarrays inside here. So what you do is you find at each, like, little streak, you want to find all your little streaks of like your numbers descending. So for example, if you can have something like this as well, right? You can have 3, 2, 1, 4, 10, 9. Sorry, let me do that. 10, 9, 8, 7, 6, 5, right? And so you know this is also going to be included, and that's going to be what, n plus 1. But this time, remember, here your n is going to be 3. And also note the following, right? What I actually did to solve it is to just count all subarrays of size 1. What I just did is I just set RV equal to the length of your array, right? This is how you would do it in Python, or in C. Like, they just pass a parameter r size, right? This is what you do. Prices. It would be prices size in the context of the problem, right? So prices size, right? That's right. So you just set your RV to that, and then note that because you already counted subarrays of size 1, how many subarrays of size 1 are inside here? There's just gonna be n, right? So 3 minus n and minus n. So yeah, so you can actually just count this. So RV is, let's just say 1, 2, 3. I'm gonna walk through this example, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, actually, I didn't even note that. Look, it's just counting to 10, but, like, in a very weird way. So yeah, just do that to count the number of subarrays. Then, okay, you have 3 times 3 plus 1, which is 4 over 2 minus 3 and then this is going to be 5. Wait, 1, 2, 3. This is gonna be 6 times 6 plus 1 over 2 minus 6. And so I think this will be like what? 3 times 2, 6 minus 3. This is gonna be 3. 6 times 7, 42, 21, 15, right? So in total, you're going to have 10 plus 15 plus 3 for this, right? And so actually what I'm going to do is I'm just going to add a test case of this array just to check if I was correct. 3, 2, 1, 4, 10, 9, 8, 7, 6, and 5. Run it. And so, yeah, that's going to be 28, which is exactly that, 28. So, yeah, this is just the approach you do. You count your number of streaks, or no, you count your streaks, and once your streak is over, you check this, right? And, yeah, I mean, I'm going to actually, I'll show a quick proof of why the number of subarrays is n times n plus 1 over 2, right? So, take an example, 4, 3, 2, 1, and note the following. How many subarrays of size 4 do you have? Right, you're going to have just one, right? Yeah, one of size 4, right? Number of subarrays of size 3 is going to be 1, 2. Of size 2 is going to be 3, right? Because, wait, let me just do this. Right, let me just draw it before. So this is your subarray of size 4. This is your subarray of size 3. This is your subarrays of size 2. And, you know, these are your low subarrays of size 1, right? And so, let me just do this. Len 4 count is going to be 1, 3 is going to be 2, 2 is going to be 3, and 1 is going to be 4. So, yeah, notice this little, oh, this is this plus 1, this is this plus 1, right? And, yeah, just notice that, right? And so, when you do that for n, right, you're going to have len is n count n minus 1 dot 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 1 is going to be 1, 2 all the way to n, right? And so after that, your goal is just to find this sum, 1 plus 2 plus n, and you this is a discrete math like introduction problem. It's just going to be by induction you prove this. And so, yeah, that's going to essentially be why the number of subarrays of an array size n is going to be n times n plus 1 over 2. So, yeah, that's the logic behind this little formula that I use. You know, I don't like to use formulas without giving the logic. And, yeah, remember that minus n, because if not, you're going to like count something you've already counted, right? Given that you already count this here. Right, so you already counted this, and you already counted this, which is why you do the minus n. But yeah, that's essentially it. I'll walk through my code a little bit. So yeah, your return value is your price's size, right? That first initialization. And yeah, you're counting the streaks with this, and you're counting if you're checking if you're on a streak using this. So yeah, loop through the array. If prices of I minus 1 minus prices of I is equal to 1, if you find this little condition right here. So if you're on a smooth descent period, and this is for if you just switch from like a non-smooth descent period to a smooth descent period, you need to set this as 1 to count this guy right here, you know? And so after that, you know, you just regular stuff, just increment your length of your streak and set your descent equal to true. And if your descent is going, and yeah, if you just got out of a descent, sorry about that. If you just got off of a smooth descent, then you know count those, right? Count that little streak you just found by using that n times n plus 1 over 2 to count those little subarrays, and then subtract the stuff that you already counted here. And yeah, set your descent equal to false, and your current descent length equal to 0. And then yeah, the reason I have this is because if you were to end in something like this, let me scroll down. If you had something like this, this is just gonna be your before part of the array. If you were to this is gonna be your before part. And let me erase this. If you were to end in something like this, and that's your end of the array, right? This is your end of the array. Notice that your code won't reach here when you have this at the end of your array. You can test that yourself, but it's basically because this condition, when you're at the last element, you get this condition and you don't end up counting it, so you need to end up counting it here. And you use the same logic of counting here, and you just return this. And note that this has to be a long, or I did a long in this I'm doing in this whatchamacallit, little submission post. I did this. But and then I'll actually go over a little bit what the editorial did. But essentially they actually used, right, the editorial actually used this right here. They basically kind of did this in their code, but it's a dynamic programming approach, blah blah blah. I'll just look at the code, right? So you have your length of your prices. Let me do in C, because this is my better language. But long result is 1. They initialize their n, that's n for here. Res is equal to 1, prev is equal to 1, and basically they literally do this right in here, and then they add it. So I'll just kind of give it what they do visually, right? So 4 3 2 1, what they do, okay, so you're here, and they just add 1 in every iteration, right? Or they just add res plus equals prev is either 1 or something above 1, right? So when you reach here, just put a bunch of dots here, and suppose this is like a 6 before, right? And then there's whatever, and this is whatever, this doesn't matter. You reach here, and basically from their code, prev is equal to 1, so rv plus equals 1, right? Or rv plus plus in this case, but rv plus equals 1 in this case. Then you get here, right? And so you're actually going to do rv plus equals 2, because notice the following. You counted this, and you're also counting this. So to count that, you need to add 2. Then when you reach here, your prev is equal to 3. So let me just p equals 1, p equals 2, and then p equals 3. So you have 1, 2, and 3, right? You don't need to count like these before that you've already counted. And you're just going to do rv plus equals 3. And that's essentially the logic behind the editorial. I didn't do it this way. I just did it like formula plug whatever type of way, and it worked for me. But that's how these people did it. And it looks like someone had a one line solution, and someone just posted their solution here. And I didn't even know there's a 2-pointer solution for this as well that people were doing, but I don't know, that's not the way I did it. But thank you guys for watching. Keep doing your Leetcode, and hopefully I get my Leetcode streak up. It used to be like, I think 40 or 50 or something, but still trying to get that Leetcode streak up. And keep doing your Leetcode. Thank you.